terms. What is physics? Physics is the study of matter and its motion through space and time, relating it to other subjects like energy and force. So physics can actually make it very simple, saying that physics is the study of matter in relation to what? Energy. So, but the study of physics, if you must learn very well what we call the study of physics, you must actually know what we call the fundamental and the derived quantities. So starting this, I want to start with what we call fundamental and derived quantities. Fundamentals and the derived quantities. Forgive my fundamental and derived quantities. What is fundamental quantities? Fundamental quantities are those quantities in which other quantities depend on for their own meaning and definition. They depend on for their own meaning and definition. Fundamental quantities are those quantities that other quantities depend on for their own meaning and definition. For example, we have fundamental quantities. Let me just give you examples of them. Fundamental quantities. And their SI units. The first fundamental quantity we have is mass. Mass is the amount of matter in a compound. Mass, and this thing is measured it what? In kilogram. The next one we have time. Time is measured in seconds. We have length. Length is measured in what? In meters. We have amount of substance. Amount of substance. We measure it in moles. In moles. Then we have luminous intensity. Which is measured in candela. So we can have temperature. Take temperature. Take temperature is amount which is measured in Kelvin. So remember what I said, that fundamental quantities are those quantities in which other quantities depend on for their own meaning and definition. So I have told you that this is the fundamental quantities we have: the mass, the time, the length, the amount of substance, luminous intensity, temperature, and the rest of it. And the SI unit. The SI unit simply means international standard. Some people have asked me, why is it international standard? Why not standard international? No, it is derived from a French word which we call Système International. That's why we call it SI unit. So its SI unit is kilogram for mass, for time is seconds, for length is meters, for amount is moles, and the rest of it. So these are the fundamental quantities. So every other quantity you see in chemistry, in physics, actually got their definition from here. So with that, I'm going to define what is derived quantities. Derived quantities are those quantities that depend on fundamental quantities for their own definition and meaning. That means fundamental quantities have their own definition and meaning, but derived quantities they don't have. They depend on fundamental quantities in order to get their definition and meaning. Just like in biology, we call it parasites. They depend on other people to get their own meaning and definition. For example, I'm going to give you examples of derived quantities. Derived quantities, I'm going to tell you how they are derived. Number one, derived quantities. Derived quantities. Quantities, their units. Okay, number one is area. Area. Area, the formula of area is length times width, and both of them has to do with length. That's how the unit, SI unit of area is what we call what? Length is measured in what? Meters. And width is still measured in meters, which is what? Times by meters, which is meter square. That's why area is what? Meter square. For example, volume. Volume, what's the formula for volume? Is length times width times breadth. I need to call it length times width times breadth. And this is still measured in what? Meters. Measured in meters. Measured in meters. That's why it's what? Meter cube. The SI unit of volume is what? Meter cube. So I want to make it, at least let's walk a little bit far from that. If I give you something called speed. Speed. What's the unit of speed? We have speed is equal to what? Distance over time. And distance is measured in what? You don't need to be told, it's measured in what? In meters. over what? Time is measured in what? Seconds. So it becomes meter per second. Some people write it this way, some people write it this way. So you can actually, let's go to velocity. Velocity. Velocity is equal to displacement over what? Time. Displacement over time, which we can also say is the same thing with this, which is equals to this. That's why we say that what? Speed and velocity, they have the same what? The same formula. But the difference is that this is actually what? A scalar quantity, while the other one is what? A vector what? Quantity. You can discover that this has displacement, and this have a specific direction, while distance doesn't have a specific. Let me do acceleration first. Acceleration is equal to rate of change in moment in velocity with time. So velocity over time is what we call acceleration. Then I've told you that velocity is equal to what? If you bring velocity down, it becomes what? Displacement over time. Remember, there is time here, there is also time here. With this, you know that this is equal to this. Add it to more time. So this becomes this becomes x, this becomes x. Remember, this is what I brought down here. So this becomes what? Meter per second square. Meter per second square. Which we can also write this way, meter per second square. Are you see? Then now coming back, I will now have to deal with what? Force. Remember, I told you force is the what? Product of what? Mass times acceleration. Mass times by what? Acceleration. Let me be using brief word of it. So this mass is equal to what? Kilogram. And acceleration is equal to what we have done here. I have done acceleration here. So it's equal to what? Meter per second square. Are you seeing it? So this makes that force is equal to kilogram meter per second square, which is equal to what? The SI unit of force, Newton. So anytime you hear Newton, another meaning of this Newton is what? Kilogram meter per second what? Square. Likewise, other this. Now I want you to also, okay, let's watch more of it. I'm cleaning this. Let's do with work. Work done. Work done is the rate of, okay, let me do it. Work done is equals to force times distance. Work is said to be done when a force is applied to an object and that object moves in the direction of that force. So we say that work is done. So work is equals to force and distance. And which what I've done to you, force is equals to what? Kilogram meter square. Kilogram meter square, as I've said before. Then times by distance, which is another what? Meter. You discover that it now become kilogram meter square per second square, which is equal to what? Joules. Joules. So whenever you hear joules, know that what? This is how it came about. Then power. I'm dealing with power now. Power is the rate of doing work. The rate at which work is done. So you can say that power is work done over time. Work done over time. So if you combine the work done I have done here, without not wasting much time, you discover that power is now kilogram meter, because square, per second cube. Per second what? Cube. Which is equal to watts. I'm trying to tell you how they derive this formula. You can see that this is how every other formula you see in physics is derived from that simple fundamental what? Quantities. In the next lesson, I'm going to teach you more about this and also enter into other topics that will help you your learning in physics. Thank you so much and bye.